In this part of the training, we will focus on drone connectivity, but specifically through the lens of frequency spectrum administration. We will explore how drones use mobile networks like 5G, what regulatory and technical requirements come into play, and why spectrum planning is critical for safe and reliable drone operations. There are several shared frequency bands available for UAV control, ranging from basic short-range bands to mobile communication bands. Typically, Wi-Fi is a popular option for UAV connectivity. However, Wi-Fi comes with limitations, particularly in terms of range and vulnerability to interference. That's why in this project we rely on 5G. The key innovation in 5G for Lives is the use of continuous mobile connectivity, which supports large volumes of data. This is essential for real-time video, control commands, and broader system integration, all made possible through 5G networks. Here we compare Wi-Fi, 4G, and 5G to understand why 5G is the most suitable option for UAV operation. Let's start with Wi-Fi. It can't really be used effectively for drone operations. It only supports visual line-of-sight flights, and there is no protection from interference. Typically, there are many other Wi-Fi networks and mobile hotspots in the same area, all sharing the same frequency band used for UAV command and control. This creates reliability and safety concerns. 4G is a step up. It allows beyond visual line-of-sight flights and provides better protection from interference signals, which is essential for extended operations. And finally, 5G. It offers everything 4G does, but with significant improvements. Faster data, transfer speeds, greater capacity, and lower latency. That means video reaches the UAV operator more quickly, enabling faster decision-making when it really matters. Drones can connect to mobile networks like 4G and 5G, just like our phones. But mobile networks in the sky are not the same as on the ground. Drones using mobile networks need special frequency bands. Since it's not safe to use just any frequency in flight, it's essential that legislation, both at EU and national levels, clearly defines which frequencies are permitted and under what conditions, to avoid interference with other critical systems. In Europe, a few specific frequency bands have been harmonized, meaning they can be used by drones in all EU countries. EU rules exist. Europe has agreed on technical rules like ECC Decision 2207 for drones using mobile signals, but each country, including Latvia, can define no-fly or no-transmit zones on its own. These so-called no-transmit zones are often established around sensitive locations like airports, weather radars, or radio telescopes, where radio silence is crucial. Individual frequency license or special permission may be required if the drone has extra radio equipment on board. This helps make sure the drone doesn't interfere with other important systems like aviation or emergency services. Think of the mobile spectrum as a big pie. If all mobile frequency bands are big pie, drones are only allowed to eat a small portion. 13 bands are available for mobile use in Latvia. Only 6 of those are permitted for UAV use. And even then, with restrictions, just 2 bands are available without any restrictions. What this means? UAV operations must be carefully planned and frequency use verified. There may be a need for more flexible, future-proof regulations. Every mission must consider where it is flying and what's allowed there. To ensure seamless operation in the 5G ecosystem, the UAV must support harmonized 5G bands depending on the design of the project, as well as consider technical regulations and planned network coverage area. It is important to understand that the theoretical calculation of network coverage will not be fully adapted to the real-world situation. So practical measurements are needed to assess network coverage for UAV operations. In this context, the 5G for Lives project developed a methodology to assess the real-life coverage and performance of the 5G new radio network in airspace corridors for UAV operations. The methodology leverages practical UAV-based measurements to validate 5G network performance in airspace corridors.